Welcome. Today, we're going to decode a powerful, hidden language that's all around you every single day. Seriously, it's a secret code that helps you make smarter decisions. And by the end of this, you'll know exactly how to read it. So let's just dive right in. So let me just ask you something. Do you think math is just for the classroom, something you left behind in school? Just a bunch of abstract numbers and problems that have no connection to the real world? Well, we're here to challenge that idea, because that so-called boring math, it's actually the hidden code behind pretty much everything you do, from cooking and shopping to planning your next road trip. It's the tool you're already using, even if you don't realize it yet. What we're going to do is unlock this everyday superpower. And this isn't about solving problems on a page, it's about seeing the world through a new, much more powerful lens. Because, understanding the world isn't just about words and sentences. It's also about numbers and the relationships between them. Learning to read that numerical code is a skill, just like reading the words you see on the screen right now. So, let's start with the very first part of our code. It's a really simple but incredibly powerful concept, the ratio. And that's it. See? No scary questions. A ratio is just a way to compare things. How much of this to how much of that. It's all about relationships between numbers. And this becomes super practical the second you step into the kitchen. Take a recipe, for example. Here we've got 2 cups of flour for every 1 cup of sugar. That's a 2-to-1 ratio. So if you want to double the recipe, you automatically know you need 4 cups of flour and 2 cups of sugar. That ratio keeps the recipe perfect. Simple, right? Okay, now that we have ratios down, let's look at their close cousin, rates. A rate is just a special kind of ratio that compares 2 different units. Think miles per hour or dollars per pound. We're going to use them to solve a few everyday puzzles. Let's start with a nice straightforward one. Imagine you see 6 buses, and you know they're carrying a total of 240 people. So how do you figure out the rate of passengers for each bus? The trick is to find what we call the unit rate. How many passengers for just one bus? And to do that, we simply divide the total passengers, 240, by the number of buses, which is 6. And that gives us our rate, 40 passengers per bus. And just like that, you solved the first puzzle. See, you've totally got this. All right, let's try a little road trip puzzle. Your car used 5 gallons of gas to go 200 miles, and you still have 500 miles to go. So how many gallons are you going to need? First things first, we find the rate. So 200 miles divided by 5 gallons gets us 40 miles per gallon. Now we just use that rate for the rest of the trip. So 500 miles divided by 40 miles per gallon means you'll need exactly 12.5 gallons. Bam! You just used a rate to plan out your journey. Okay, this next one is a classic, but it can be a little tricky. If 3 workers can build a wall in 6 days, how long would it take 6 workers? Now your first thought might be, hey, double the workers, half the time. And you'd be right, but let's actually see why that works using rates. So the key here is to first figure out the total amount of work needed. We do that by multiplying the 3 workers by the 6 days, which equals 18 worker days. That's our total effort. Now we just divide that total effort by our new, bigger team of 6 workers. And we get our answer, 3 days. It confirms our intuition. You didn't just guess, you actually proved it with math. And it's interesting, the source material for this puzzle actually connects this mathematical idea, that a set amount of work has to get done, to a much broader philosophical principle about effort and reward, which is summed up by this quote. All right, you ready for the boss level? This one's got a few more moving parts, but don't worry, we have all the tools we need. So here's the deal. 4 people paint 8 walls in 2 days. The question is, how many walls can 6 people paint in 3 days? Okay, before we even touch the math, let's just get organized. Laying it all out in a table like this makes a huge difference. We've got our starting scenario on the left and our target scenario on the right. The only way to crack this is to find the most basic rate of all. How many walls can just one person paint in one single day? So we find that by taking the 8 walls and dividing by the total effort. That's 4 people times 2 days. This gives us a really simple rate of 1 wall per person per day. Now we can apply that to our new situation. 1 wall times our 6 people times our 3 days, which gives us our final answer, 18 walls. See? By breaking it down, even a complex problem becomes totally manageable. Great job. So what was the point of all this? Well, you haven't just learned to solve a few random math puzzles. You've learned how to code the numbers that shape your decisions every single day. You've just gained a new, powerful, real-world skill. I mean, think about what this code lets you do. You can instantly calculate a 20% discount at a store. You can actually understand your car's fuel efficiency. You can analyze sports stats, or quickly figure out what all those percentages on a nutrition label really mean. At the end of the day, this isn't just about math anymore. It's about clarity. It's about making smarter, more informed choices in your life. So the only question left is, now that you have the tools to decode the world around you, what will you solve first?